Good evening, my dear students. So today in these sessions we are going to learn Unit 3rd. In the Unit 3rd we are going to learn the first topic is chemical energy. So what is the meaning of chemical energy? Chemical energy, it is one type of the energy. Chemical energy, it is one type of energy stored in the bond of chemical compound. So chemical energy may be released or may be absorbed during a chemical reaction in the form of heat. The such reaction we can say as exothermic reaction. For example, burning of wood, it is example of chemical energy. And whatever we are eating the food, this food is converted into the chemical form. So it is one type of the chemical energy. And second topic in the chemical energy is combustions of fuels. Okay, combustion is one type of the oxidation process in which fuels combine with oxygen with accompanying release of heat. Combustion, it is one type of the oxidation process in which fuels combine with oxygen accompanying release of heat. So in the combustion of fuels, the air is most convenient source of oxygen. Air is most convenient source of oxygen is usually employed to burn the fuels. Without the air, you can't burn the fuels. Air is play very important source to burn the fuels. Combustion is a surface phenomena and it would be accelerated provide the fuel particle to reduce the lower size. For efficient combustion of fuels, three factors are very important. The first one is temperature for the efficient combustion of fuel purpose. Second one is time, and third one is turbulence. And third topic is combustion of coal. Okay, combustion of coal is made of fixed carbon and partial volatile matters. The combustion of coal, these react with oxygen in the air in the presence of some heat to form their respective oxides and release the large quantity of heat So as well as in the combustion of coal, air requirement for 1 kg of coal is having the 84% of carbon and 6% of hydrogen and 2.5% of nitrogen and 7% of oxygen and 0.5% of sulfur on dry mineral matter, free bases will require. So theoretically 11.54 kg of air, of which 2.725 kg is oxygen, is required for complete combustion purpose. If for any reason air supplies is inadequate, the combustions will be incomplete. So if you are not supply the air properly, so due to incomplete combustions will be occurring. As per as requirement, we need to supply the sufficient amount of air, then it causes complete combustions will occur. The result is poor generate of heat because the some portion of carbon remain unburned. So the some amount of carbon, it is not burned properly, and it causes the forming of carbon monoxide instead of carbon dioxide. So if you burn completely, then coal will produce the carbon dioxide. If the coal is not burned properly, then it will produce the carbon monoxide. Carbon monoxide, it is harmful to the human being, those that exist on the universe. Okay, dear? Next one is boiler. Because almost all students is aware about the boilers. So a steam boiler is a closed vessel in which water is heated. So we need to heat the water. This water is vaporized, and this vaporized converted into the steam at a pressure higher than atmospheric pressure. So boilers are classified. The first one is according to circulations of gases, in which we are using the 5 tube boiler or water tube boilers we are using. If we are considering the according to circulation of water, like free circulation or by force circulations of water, okay, as well as according to number of tubes, maybe single tube boiler or it may be multi-tube boiler. And fourth one is according to pressure. If the pressures of the boiler, if it is more than 80 bar, so we can say as high pressure boiler. If the pressures of the boiler if it is lies in between from 20 to 80 bar, we can see as medium pressure boiler. If the pressures of the bar, if it is lies in between 15 to 20 bar, we can say as low pressure boiler. As well as, according to position of axis of the boiler shells, the boiler position may be sometime horizontal positions of the boiler shell, or sometime the vertical positions of the axis of the boiler shells. Okay dear, so how to find out the boiler efficiency? The boiler efficiency defined as it is a ratio of heat output by heat input multiplied by 100, then you will get the boiler efficiency. Is it right? What are the various heat losses in boiler? They having the different types of heat losses in the boiler, like dry flue gas losses, hydrogen losses, moistures in fuel losses, carbon monoxide losses, moisture in air losses, fly ash losses, bottom ash losses. They are having the different type of heat losses in the boiler. Let us see this figure. The boilers in which we are insert the water as well as we insert the air, as well as we insert the fuel input 100%. If you insert the water, we need to heat the boiler up to vaporize, and this vaporize is converted into the steam output. From this boiler, the flue gases sample like dry flue gas losses, hydrogen losses, moistures in fuel losses, moistures in air losses, and surplus losses, carbon monoxide losses, fly ash losses, as well as bottom ash losses. Is it right? So following losses are applicable to the solid, liquid and gases boilers. So L1 is represent the loss due to dry flue gas, we can say as sensible heat. L2 is represent the loss due to the hydrogen in fuels. L3 represent the loss due to moistures in the fuels. How much amount of moistures in the fuels? L4 is represent the losses due to the moistures in the air. L5 represent the losses due to carbon monoxide. L6 is represent the losses due to the surface radiation, convection and other unaccounted. Is it right? And losses are insignificant and it is very difficult to measure. The following losses are applicable only for solid fuels fired boiler in the addition to above. Like L7, this L7 is only mainly used for solid fuel fired boiler purpose. We are using this L7. L7 is represent the unburned losses in the fly ash. Like carbon in the sense we can say as coal. Okay, the coal is a one type of these solid fuels fire object. And L8 is represent the unburned losses in the bottom of the ash. So if you want to find out the boiler efficiency by the indirect method, the first one is 100 minus of L1 plus L2 plus L3 plus L4 plus L5 plus L6 and L7. Okay. So 100 minus L1 is indicate that the loss due to dry flue gases. L1 is indicate losses due to dry flue gases in a sensible heat, and L2 is represent the losses due to the hydrogen in fuels, and L3 is represent the losses due to the moistures in fuels. L4 is represent the loss due to the moistures in the air. L5 is represent the losses due to the carbon monoxide, and L6 represent the losses due to the surface radiation and convection, and L7 is represent the unburned losses in the fly ash, and L8 is represent the unburned losses in the bottom of the ash. So if you want to find out, if you want to find out the value of L1 is equal to M is indicate that the mass of dry flue gases in kg, and Cp represent the specific heat capacity of the air, and Tf is represent the final temperature, minus Ta is indicate the ambient temperature, divided by gross calorific value of fuel multiplied by 100. From that one you can easily get the value of L1 value. Then how to find out the value of L2? L2 equal to 9 into hydrogen into 584. Why I am using this 584? Because of latent heat purpose we are using the 584. Because whatever we heat the water is vaporized. Is it right? So for that reasons we are using the 584. Plus Cp is indicate that specific heat capacity of the air, and Tf is indicate that final temperatures, minus ambient temperature by Gcv is represent the gross calorific value of the fuel multiplied by 100. Then you will get the value of L2. If you want to find out the value of L3, M is represent the how much amount of moisture is present in the fuel on 1 kg basis. This 584 is mainly used for latent heat. If you heat the water, this water is vaporized, and this vaporized is converted into the steam. Then for that reasons we are using this standard value of 584. Plus Cp is the specific heat capacity of the air. Final Tf is represent the final temperature minus ambient temperature by gross calorific value of the fuel multiplied by 100. Okay, and if you want to find out the value of L4 is represent the AAS. A is nothing but actual mass of air supplied per kg fuel. Is it right? Into humidity factor into specific heat capacity in the bracket final temperature minus initial temperature multiplied by 100 by gross calorific value of the fuels. From that one we can easily find out the value of L4. If you want to find out the value of L5 is equal to how much percentage of carbon monoxide into carbon divided by percentage of carbon monoxide plus percentage of carbon dioxide into gross calorific value of the fuel into 5744 into 100. Okay, so we understood that we can easily find out with L1, L2, L3 and L4, L5 value. If you want to find out the value of L6 is 0.548 into TS. So what is the meaning of TS? The TS nothing but saturated temperature divided by 55.55 power of 4 minus of ambient temperature divided by 55.55 power of 4 plus 1.957 saturated temperature minus initial temperature. So 196.85 VM. VM nothing but the virtuous machines plus 68.9 divided by 68.9. From that one you can easily find out the value of L6. So if you want to find out the value of L7 nothing but how much total amount of ash collected per kg of fuel. How much amount of ash collected per kg of fuel burned into gross calorific value of fly ash multiplied by 100 divided by gross calorific value of the fuel. From that one we can easily get the value of L7. What about the L8? L8 is represent the total ash collected. Total ash collected per kg of fuel burned into gross calorific value of bottom of the ash into 100 divided by gross calorific value of the fuels. Okay, so in the next session we are going to learn regarding the internal combustion engine. I hope so no one is having the doubt regarding the up to here. Is it right? If you have a small doubt also you can write down in the comment box, and please don't forget to subscribe my channel. Thank you.